Chapter 8, the D and F block element. Objective. After studying this unit, you will be able to learn the position of D and F block element in the periodic table, know the electronic configuration of the transition D block and F block element, appreciate the relative stability of various oxidation states in terms of electrode potential values, describe the preparation properties, structures, and uses of some important compound such as K2Cr2O7 and KMNO4. Understand the general characteristics of the D and F block element and the general horizontal and the group trend in them. Describe the properties of F block element and give it a comparative account of lanthanoids and actinoids with respect to their electronic configuration, oxidation state, and chemical behavior. Iron, copper, silver, and gold are among the transition elements that have played an important roles in the development of human civilization. The inner transition elements such as thorium, Pa, and U are providing excellent sources of nuclear energy in modern time. The D block of the periodic table contains the elements of the group 3 to 12 in which the d orbital are progressively filled in each of the 4 long periods. The F block consists of elements in which the 4f and 5f orbital are progressively filled. They are placed in a separate panel at the bottom of the periodic table. The name transition metal and inner transition metal are often used to refer to the elements of the D and F block respectively. There are mainly four series of the transition metal: 3D series scandium to zinc, 4D series ytterbium to cadmium, 5D series lanthanum and hafnium to mercury, 6D series which has actinium and elements from Rf to Cn. The two series of the inner transition metal, the 4f cesium to lutetium and 5f thorium to lawrencium, are known as the lanthanoids and actinoids respectively. Originally, the name transition metal was derived from the fact that their chemical properties were transition between those of S and P block element. Now, according to the IUPAC, the transition metal are defined as metal which have incomplete d subshell either in the neutral atom or in their ion. Zinc, cadmium, and mercury of group 12 have full D10 configuration in their ground state as well as in their common oxidation state, and hence they are not regarded as a transition metal. However, being the end members of the 3D, 4D, and 5D transition series respectively, their chemistry is studied along with the chemistry of the transition metal. The presence of partially filled D and F orbitals in their atoms make the transition elements different from that of the non-transition element. Hence, transition element and their compound are studied separately. However, the usual theory of valence as application to the non-transition element can be applied successfully to the transition element also. Various precious metals such as silver, gold, and platinum, and industrially important metals like iron, copper, and titanium belong to the transition metal series. In this unit, we shall first deal with the electronic configuration, occurrence, and general characteristics of the transition element with a special emphasis on the trends and the properties of the first row 3D transition metal along with the preparation and the properties of some important compound. This will be followed by consideration of certain general aspects such as electronic configuration, oxidation state, chemical reactivity of the